Hello students, let us continue with exercise 7.3 of chapter 7 triangles. So we completed the first two questions, now we proceed with the third question onwards and complete the exercise. So the third question, we have two triangles. It's been given that AB is equal to PQ. So which AB and PQ are marked with single dashes, then BC is equal to QR. So this entire line segment BC is equal to the entire line segment QR, and AM is equal to PN. So AM and PN are equal. It's also been given that AM and PN are the medians. So what is a median? A median is a line that connects the opposite vertex to the opposite connects the vertex to the opposite side's midpoint, which means M is the midpoint of BC and N is the midpoint of QR. Now what do we need to do? We need to prove that triangle ABM and triangle PQN are congruent. So let us see how we are going to prove the two triangles congruent. If you notice triangle ABM and triangle PQN, we have been given that sides AB and PQ are equal, also that AM and PN are equal. Now M is the midpoint of BC and N is the midpoint of QR. So half of BC is going to be equal to half of QR, correct? Half of BC is BM, so BM is going to be, and half of QR is QN. So BM is equal to QN. Therefore, in triangles ABM and PQN, we have the three sides equal. Therefore, the two triangles are congruent by the side angle test of congruence. Side test of congruence, not side angle test, it's SSS. So let's go ahead and prove the first part. So I'll say 3, 1. So first of all, what am I going to say? M is the midpoint, or rather, since AM is the median of triangle ABC, M is the midpoint of BC, correct? Therefore, BM is equal to half of BC, and I'll mark this as 1. Again, since PN is the midpoint or median, of triangle ABC, N is the midpoint of QR. Therefore, what can I say? That QN is equal to half of QR, and I'll mark this as 2. But we've been given that BC is equal to QR, which is given, correct? Therefore, half of BC is equal to half of QR. But what do we have? Half of BC? BM. So I'll say BM is equal to half of QR is QN, and I'll say from 1, I'll mark this as 3. So from 1, 2 and 3. What do we have from 1 and 2? BM is equal to half of BC and QN is half of QR, and the third point is half of BC is equal to half of QR. This statement, I will mark this as 4. Okay, I have marked this 4 not because I have less space here, but this is just to clarify that we will be using this while proving the two triangles congruent, that is ABM and PQN. Okay, so now in triangle ABM and triangle PQN, what do we have? AB is equal to PQ and AM is equal to PN, both are given. And what else do we have? That BM is equal to QN. So I'll say from 4. Therefore, the two triangles are congruent by SSS test. Therefore, triangle ABM is congruent to triangle PQN by SSS, which is side test of congruence. Now I need to prove that triangle ABC is congruent to triangle PQR. So my triangle ABC is this and triangle PQR is this. How am I going to prove these congruent? First of all, you prove these two triangles congruent. That's ABM and PQN. Therefore, what can you say? That angle ABM is equal to angle PQN. But if I extend M to C, it becomes ABC is equal to, and if I extend N to R, I get AQR. So that is angle ABC is equal to angle PQR. So now for the two triangles ABC and PQR, what do I have? I've been given that AB is equal to PQ, then angle B is equal to angle ABC is equal to angle PQR, we just proved that, and also I can say that BC is equal to QR, which is given. Therefore, the two triangles are congruent by the side angle side test of congruence, which is nothing but SAS. So let's go ahead and write this. So my second part, I'll say that triangle ABM is congruent to triangle PQN. Correct? Proved above. Therefore, what do I have? Angle ABM is equal to angle ABN. I'll say CPCT, that is congruent parts of congruent triangles. But extending M and N to C and R respectively, what do we get? Therefore, angle ABC is equal to angle, this is PQN, is equal to PQR. Correct? And I'll mark this as 5. So now let's take the two triangles. So in triangle ABC and triangle PQR, AB is equal to AC given, angle ABC is equal to angle PQR, I'll say from 5, and finally BC is equal to QR, which is given. Therefore, what can I say? That my triangles are congruent. That is, therefore, triangle ABC is congruent to triangle PQR by side angle side test of congruence. Hence, both of these are proved. Correct? Let's move on to question number 4. So, I am erasing the board. I hope you've taken notes. So, I have been given that BC is equal to CF are two altitudes of triangle ABC. So, first of all, I am going to go ahead and draw my triangle ABC. And altitudes are nothing but perpendiculars drawn from one vertex to the opposite side. So, I have BC and CF. It will be BE and CF. So, BE and CF are the two perpendiculars or the two altitudes. So, each of these is 90 degrees. What do I need to prove? That the triangle ABC is isosceles by right RHS test of congruence. So, RHS is nothing but right angle hypotenuse side test of congruence. So, how are we going to prove that? First of all, in order to prove that triangle ABC is isosceles, I need to prove that AB is equal to AC, or I can even prove that angle B is equal to angle C. But looking at this, what data have we been given? That only BE is equal to CF. So, these two sides are equal, right? BE, this entire length, okay, is equal to CF. Do you think it doesn't really look possible to prove with the given data that AB is equal to AC? But if you take the two triangles, let me draw these two triangles for you. So B, F, C and B, C, E. I've been given that these two sides are equal. Okay. Also, this is the common base, right? This is the right angle. Now, since these are the right angles, this is my hypotenuse and this is my hypotenuse, and I have one side equal. Correct? So, what can I say? That the two triangles BFC and CEB are congruent by which side? Which test? RHS test, which is the right hand side test of right angle hypotenuse side test of congruence. Therefore, what can I say? That these two angles are equal to each other, which are FBC and ECB, correct, or CBF and BCE. But if I extend the point F to reach A, what will I have? CBA is equal to BCA, which means that these are the opposite angles of a triangle, opposite angles of base angles of isosceles triangle, correct. Now, since they are equal to each other, that means the sides opposite these angles are also equal, which makes the triangle isosceles, right. So, let us prove this. So, in my triangle BFC and triangle CEB, what do I have? Angle BFC is equal to angle CEB. Each is equal to 90 degrees because they are the altitudes, correct. Therefore, hypotenuse BC is equal to hypotenuse CB. See, I am taking BC over here, B corresponds to C and C corresponds to B. Therefore, hypotenuse BC is equal to hypotenuse CB. I will say common side, correct. Also, I have FC is equal to EB. Or let us see how they have given it to us. BE is equal to CF. So, CF is equal to BE, which is given. Therefore, what can I say? That therefore, triangle BFC is congruent to triangle CEB by RHS test. Therefore, now let us prove these angles congruent, that is CBF and BCE. Therefore, angle CBF is equal to angle BCE, which implies CBA is equal to BCA, correct. Therefore, angle CBA is equal to angle BCA, which implies that the opposite sides are equal. So, which is the opposite side to my angle B? It's going to be AC is equal to AB, correct. Therefore, triangle ABC is isosceles with AB is equal to AC, correct. So, it is proved, and RHS test has been used over here in proving these two small triangles congruent to each other. Now, let us move on to question number 5. Again, in question number 5, we do not have a diagram, so we will draw it. We have ABC is an isosceles triangle with AB is equal to AC, and P is a point on BC such that AP is perpendicular to BC. So, let us draw the diagram first. ABC, AB is equal to BC, we have AP perpendicular to BC. So, each of these is 90 degrees. you need to prove that angle B is equal to angle C. So, if you see, I have two triangles formed, ABP and ACP. Now, for these two triangles, this is AB is the hypotenuse and AC is the hypotenuse. So, the hypotenuse are equal and we have a common side. Therefore, the two triangles ABP and ACP are congruent to each other by the RHS test of congruence. Therefore, I can easily say that angle B is equal to angle C. Why? Corresponding parts of congruent triangles. So, let us solve this, or let us prove this. I will say proof in triangle ABP and triangle ACP, I have angle APB is equal to angle APC, each is equal to 90 degrees. Therefore, hypotenuse AB is equal to hypotenuse AC, which is given. Also, AP is equal to AP. Why? Common side. Therefore, what can I say? Therefore, triangle ABP is congruent to triangle ACP by RHS test. Therefore, angle B is equal to angle C, corresponding parts of congruent triangles or CPCT. So, this was the last last question of your exercise number 7.3. We will take a look at the remaining topics of chapter 7 in the forthcoming classes. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.